Hey peeps, it's Sophie here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're dealing with the Grade 11 2018 Physical Science paper, and this is a question on optics. Okay, so let's get into it. It says, a glass prism is placed at the bottom of a container and filled with water. A light ray passes from the air through the water into the glass prism. The light ray changes direction every time it passes into a new medium. Name the phenomenon described by the underlined words above. So the underlined words are a light ray changes direction every time it passes into a new medium. We know that that is refraction. Okay. So 7.2 says, if the refractive index of water and air is 1.33 and 1 respectively, calculate the angle theta between the light ray and the surface of the water if the angle of refraction in the water is 40 degrees. Okay, so I've got a little picture on the side here. So we're just going to draw the incident ray and the refracted ray. So we know that if a ray comes in and hits the surface of the boundary of the air and water, it's going to be refracted. Okay, so if we draw a normal or perpendicular line to there, we are given that the angle of refraction in the water is 40 degrees. So this angle over here is 40. Great, so we're looking for this angle, which would be our incident angle, and 40 would be our refraction angle. You just put directions on these. Okay, so let's get started. So we know that the formula for these is the incident ray, which is n incident sine of the incident angle, which I've marked as theta I there, and that is equal to the refracted ray sine of the refracted angle. Cool. So we know that the incident ray, which is coming from air, the refractive index of it is just 1, and we know that the refractive index of the refracted part, which is water, is 1.33, and that's given. Cool. So if we do the calculation, we end up getting 1 sine theta incident, which we don't know, we're working out theta incident, is equal to 1.33 sine of theta refracted, and we know that that is 40 degrees because that is given. Cool, and then if we put that all in our calculator, we get the incident angle is equal to 58.75 degrees. But they have asked for the angle between the light ray and the surface of the water, which is actually this angle here, this angle theta. So how do we get that angle? It's simply the complementary angle of what we just found. So theta is equal to 90 degrees minus 58.75 degrees. And that is 31.25 degrees. Cool, so that's angle theta. Okay, so the next question says that the angle of refraction in the glass is 35 degrees. Calculate the refractive index of the glass. So we're just going to start with the same formula again, and that is the incident refractive index, sine times the incident refracted angle is equal to the refracted thing, sine of the refracted angle. Okay, so we are looking for the refractive index of glass, which is this one over there, this NR. Great, so if we plug in everything we know that the incident refractive index is of water, and we know that that's 1.33, which was given. Sine, and we know that the angle, the refracted angle of water is 40 degrees because that's given. We don't know what NR is, but we do know that this angle is 35 degrees. So if we put that all in our calculator, we get the refractive index of glass to be 1.49. That looks like 9. This is a 1. Cool. So that's 7.3. Okay, so 7.4 requires us to draw a sketch. So let's just erase some of these things and just remember our answers. Okay, so it says draw the sketch below and complete the diagram of the path of the light ray from the air to the water to the glass. Show all values of the angles of incidence, angles of refraction, and normal in each medium. Okay, great. So I'm just going to use this little block over here, and we have a few of them, but let's just erase the stuff we don't need. Okay, so we first of all can track the path of this thing. So we know that this ray is going to come down and it's going to be refracted into the water, and then that is going to refract further into the glass. Cool. And we can draw little normal angles there, because they need those angles. So let's start with what we're given. We know that the angle of refraction in glass is 35 degrees, so we know that angle. And we worked out that the angle of incidence is 58.75 for air to water. Cool. And then we also, oh, well, that's all the information we need. We only need the refracted angles, and we need the normal lines, which is exactly what we've got. We've been given all the other information. Great. Okay, so then we can move on to 7.5, and that question says we need to calculate the speed of light through the glass prism if the refractive index of glass is 1.5. Now this uses a different formula. It is N is equal to C over V. So we know that C is the speed of light, which is 3 times 10 to the 8 meters per second. And then we know that V is obviously the velocity that we're working out. That is the velocity of the light ray. And N is the refractive index. So we were given that the refractive index is 1.5. We know the speed of light in air is 3 times 10 to the 8, and we're solving for V. So then we get V is equal to 2.8 times 10 to the 8 meters per second. So that's how fast this light ray travels through glass. Great. So the next one says, is it possible that total internal reflection of the light ray can occur in the above situation? Write yes or no. So we know reflection occurs, well, total internal reflection occurs when we have a high refractive index on top and a low refractive index at the bottom, and a ray comes and it's incident at some critical angle, and it total internal reflection occurs. But in this case, the light goes from air to water to glass, which means that the refractive index is always increasing as going through these media. So total internal reflection actually can't happen because it's going from low to high and not from high to low. So the answer to 7.6 is just no. Okay, so that is it for this question. But before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. Also, be sure to visit our website for more of these epic tutorial videos. And if you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. But until next time, stay epic.